everyone. Welcome to homework 5.11. So today we looked more at the quadratic formula, but with specific situations. So we have this first one where Maya and Jada are solving this equation, but they found different solutions. If this equation is written in standard form, what are the values of A, B, and C? So let's look at the equation itself. This is the equation here. Now notice this is almost in standard form, but our constant is on the other side. So I'm going to rewrite this as, let's see, it's 2x squared minus 7x equals 15. So I'm going to start by subtracting 15 from both sides because I want to write this as ax squared plus bx plus c equals 0. So this is 2x squared minus 7x minus 15 equals 0. That means a equals 2, b equals negative 7, and c equals negative 15. Do you agree with either one? Explain your reasoning. So let's take a look at what they did. So again, we said that A is 2, B is negative 7, and C is negative 15. So I wrote negative 7 plus or minus the square root of 7 squared minus 4 times 2 times negative 15. So here immediately I see a problem because the equation is negative B. And if it's negative B and B equals negative 7, then that is a negative 7. So this should become a positive 7. Let's take a look at Jada and see what Jada did. So Jada put the negative 7. All right, so that part checks out. Plus or minus negative 7 squared minus 4 times 2 times negative 15. All right, now notice here, remember what I keep telling you, underneath that radical, use parentheses, because Jada then wrote that negative 7 squared is negative 49. But remember that this is b squared, so it's all of b. So negative 7 squared is negative 7 times negative 7, which is positive 49. So here, Jada, while she did the negative 7 part correct, she messed up the negative 7 squared. So no, because my incorrectly wrote b as positive 7, and Jada did not square negative 7 times negative 7 to be positive 49. All right, number 2, the equation h of t equals negative 16t squared plus 80t plus 64 and represents the height and feet of a potato t seconds after it was launched from a device. Write an equation that would allow us to find the time the potato hits the ground. So this would be negative 16t squared plus 80t plus 64 equals 0. It says solve the equation without graphing, show your reasoning. So in this case, I'm going to go ahead and use my quadratic formula. So I have A is negative 16, B is 80, and C is 64. Negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. All right. Now we have some big numbers here, but that's okay. We can use a calculator. Oops, forgot my plus or minus. That's important. Negative 80 plus or minus the square root of. So we will get 80 times 80, which is 6,400, minus. We're going to have a negative times a positive. So that's going to leave me with a positive. So 4 times 16 times 64 is 4,096. And again, that's plus because we have a negative times a negative, which gives us a positive, and then a positive times a positive, which gives us a positive. And then 2 times negative 16 is negative 32. Now for this part, the key is that we're going to start by taking care of what is underneath the radical. So I'm going to rewrite this. I'm going to do it above for spaces. Negative 80 plus or minus the square root of 6,400 plus 4096 is 10,496 divided by negative 32. All right, so now I have to take the square root of 10,496, and it's going to give me, again, we're going to estimate because it's not going to give me a perfect square. So this would be negative 80 plus or minus the square, or plus or minus the square root of 10,496 is about 102.45. So I'm going to write this as 102.45 all over negative 32. And now you can calculate your numerator and then divide by your denominator. So we're going to do negative 80 plus 102.45 divided by negative 32, which will give us negative 0.7 as one answer. So that would be t equals negative 0.7. So in our situation, we know that when we're talking about something being launched, negative time is not helpful for us. So we're probably not going to want to consider that answer. That means our other answer should be positive. Let's see. If we get negative 80 minus 102.45 divided by negative 32, we get t equals 5.7, and that makes sense because at 5.7 seconds, then our potato has hit the ground. And if you'd like to, you can double check that answer by graphing. All right, number 3. Priya found x equals 3 and x equals negative 1 as solutions. Is she correct? Show how you know. So for number 3, you can solve this any way that you would like. You can factor it, you can complete the square, or you can use the quadratic formula. It doesn't matter. But you want to prove that 3 and negative 1 are solutions. You can also plug in 3 and then plug in negative 1 and show that both of them will equal 0. For the purposes of this, I'm going to do factoring because we haven't done that in a while. So 3 times negative 9 is negative 27. Factors that multiply to give us negative 27 and add to give negative 6 are negative 9x and positive 3x. And so I'm going to rewrite my equation as 3x squared minus 9x plus 3x minus 9. And then I'm going to do the backwards box. So 3x squared and 3x have 3x in common. And then what's left here would be x. 3x times x gives me 3x squared. That means to get negative 9, I'm going to multiply negative 9 times x to get negative 9x. And then here, negative 9 would be a, let's see here. Going to be a plus 1. Okay, and so when we calculate this now, we'll get 3x minus 9 times x plus 1. We can check, we get 3x squared, we get negative 9x and positive 3x, which gives us negative 6x, and 9 times negative 9 times 1 gives us negative 9. And so now I can solve for each of these. So I can set up 3x minus 9 equals 0, add 9 to both sides, we get 3x equals 9, x equals 3. X plus 1 equals 0, subtract 1 on both sides, we get x equals negative 1. Okay, so I proved this by factoring. You can prove this by completing the square or by using the quadratic formula as well. I would actually ask that you choose the one you struggle with the most, right, so that you practice it. All right, number 4. Lynn says she can tell that 25x squared plus 40x plus 16 and 49x squared plus 112x plus 64 are perfect squares because each expression has the following characteristics, which she saw in other perfect squares in standard form. The first term is a perfect square. The last term is also a perfect square. Yep, that's true. If we multiply a square root of the first term and a square root of the last term, and then double the product, the result is the middle term. So it says show that each expression has the characteristics Lynn described. All right, so square root of 25 is 5, and the square root of 49 is 7. Oh, I'm sorry, of 16. Looking here. Okay, 16 is 4. Okay. If we multiply, so the first term's a perfect square, the last term's a perfect square. That checks out for equation 1. If we multiply a square root of the first term and a square root of the last term, so 5 times 4 is 20, and then double it, so times 2, we get 40, which is the middle term. That is true. Let's look at the next one. So we have 49, square root of 49 is 7, and then 64 has a perfect square root of 8. If we take 7 times 8, we get 56, and then 56 times 2 gives us 112. Now, in this case, we would need to be careful because we're looking at that negative 7 and negative 8 in this case to give us this negative 112 in the middle. Okay, but yes, that does add up to give us that middle term or the linear term. Then it says, write each expression in factored form. So if we know that they're perfect squares, then we can look at the first and last term to help us create our perfect square. Now, remember that this is the same as 5x plus 4 times 5x plus 4. And so if I write this, I'll multiply 5 times 5 is 25x squared, plus 20x is plus 40x, that's our middle term, and then 4 times 4 is 16, our last terms. Okay, and then our other one we can also write as 7x, and our end term is 64, so that'll be 8. Now here we want to have a minus because we want our middle term to have that negative 112, as I talked about before. So again, this is the same as 7x minus 8 times 7x minus 8. And if we were to multiply the first terms, we get 49x squared. My outer term gives me negative 56x. My inner terms give us another negative 56x. And then my last terms, negative 8 times negative 8 gives me positive 64. So if I look at this again, I get 49x squared minus 112x plus 64, which is in fact our original equation. All right, number 5 says, what are the solutions to the equation 2x squared minus 5x minus 1 equals 0? So it asks, what are the solutions? Which of these is true? All right. Now you can see they all have imperfect square roots, right? So we're going to look at using the quadratic formula here. So A is 2, B is negative 5, and C equals negative 1. So negative 5 plus or minus the square root of negative 5 squared minus 4 times A times C all over 2 times A. This becomes positive 5, so that helps me. I can eliminate A and C, plus or minus the square root of negative 5 squared is 25. Negative 4 times 2 is negative 8. Negative 8 times negative 1 is positive 8, all over 4. So this is going to be 5 plus or minus the square root of 33, all over 4. So D is my best answer. Let's take a look now at letter number 6. Solve each equation by rewriting the quadratic expression in factored form and using the zero product property or completing the square. So we get to choose which one we want to do here. This first one I'm going to do by factoring because my middle term has an 11. So completing the square would be really annoying because dividing 11 by 2 is going to give us a decimal or a fraction, right? So immediately I know I want to factor. And I want to think about factors of 24 that add up to 11. So we have 2 and 12, 6 and 4, 8 and 3. There we go. So 8 and 3. And then we can set each factor to equal 0 and solve. So we have x plus 8 equals 0, and x plus 3 equals 0, x equals negative 8, x equals negative 3 are our answers. For this one here, My middle term is an even number, but notice my first term is also a perfect square of 2, and my last term is a perfect square of 5. 5 times 2 is 10, and 10 times 2 is 20. So this actually looks like it's already a perfect square, but let's see if it is. If I were to write this as 2x plus 5 times 2x plus 5, will I get this? Well, 2 times 2x is 4x squared. My outside, 2x times 5x is 10x. My inside, another 10x. And then my last plus 25 is 4x squared plus 20x plus 25. So this is in fact a perfect square already. I don't need to complete the square, or so I can just use my factors. And in this case, because my factors are the same, I will only have one solution. So I can subtract 5 from both sides. We get 2x equals negative 5, x equals negative 5 over 2. Okay, for this one, I'm going to start by moving the 5 to the left side. And so now it's in standard form. So factoring here is going to be kind of annoying, and completing the square would work, and so would using the quadratic formula. So actually, if I use the quadratic formula, I'm sorry, if I use completing the square, leaving it with the 5 on this side isn't a bad idea, because I can take half of 8, which is 4, and then square it. So 8 divided by 2 gives me 4, and then 4 squared is 16. And I can add 16 to both sides. And so now I get x plus 4 squared equals 21, and I can take the square root of both sides. Now I will get a number that is not a perfect square here, and that is okay. So you can still calculate this and get x equals negative 4 plus or minus the square root of 21 there by completing the square. If we use the quadratic formula, we'll get the same thing. So let me just show you that. We have 1, 8, and 5. This would be negative 5. So a equals 1, b equals 8, and c equals negative 5, because I'm going to move this to the other side to make it equal to 0. So negative 8 plus or minus the square root of 8 squared minus 4 times a times c all over 2 times a. This then is negative 8 plus or minus the square root of 64 minus 4 times 1 times negative 5. So a negative 4 times 1 is negative 4. Negative 4 times negative 5 is positive 20 all over 2. So now you will have negative 8 plus or minus the square root of 84 all over 2. Now, here's the thing. We are going to want to break up this 84 a little bit. These two, believe it or not, are equivalent. So 84 divided by 4 gives us 21. So this is the same as negative 8 plus or minus the square root of 4 times 21 divided by 2. So we can break this up as negative 8 plus or minus the square root of 4 is 2 times the square root of 21 over 2. Now I can divide negative 8 divided by 2. There we go. Okay, negative 8 divided by 2 is negative 4. Plus or minus 2 divided by 2 is 1. So that's the square root of 21. So that is equivalent. If you were to actually put that in the calculator and get the square root of 21, or get the square root of 84 and then divide by 2, you will get the same answer. So number 7 is a review, and this is our exponential decay. And remember that when we're multiplying by our fraction, that's how much is left. So the greater the fraction, the greater amount that is left, and that also means the slower the decay. And so in this particular scenario, b is decaying by quite a lot because it is only remaining 1/4. And so that one's decaying the fastest. So B is graph Z because it's decaying faster. Now notice y and x are very close to each other. And that's because 2/3 and 3/5 are relatively close to each other. 2/3 is about 67%, so it's retaining 67%, whereas 3/5 is retaining 60%. And so C would be letter Y, and A would be letter X, because A is actually retaining the most amount of its value. It's retaining 2/3 or 67% of its value. Number 8, the function f of x, or sorry, the function f is defined by f of x equals x plus 1 times x plus 6. What are the x-intercepts of the graph? So we have -1 and -6. So we can go ahead and plot those points. It says find the coordinates of the vertex of the graph. So remember the vertex is the midpoint. So 1, 2, and then 1, 2. It would be in between those two. And we can also calculate -1 plus -6 divided by 2, which gives us -7 divided by 2, which gives us -3.5. So it's going to be in between -4 and -3, -3.5. And then we need to figure out what the y value is. So if we have -3.5 plus 1 times -3.5 plus 6, we will get -2.5 times positive 2.5. And so you'll get, I believe, 5.25. So 2.5 times -2.5 is, oh, sorry, just kidding, is -6.25. And so the y value of our vertex will be just below -6, about here. And so this is what our graph will look like. Okay, so remember, when you have the x-intercepts, you can use them to find the midpoint, and that will give you where the x value of your vertex. Once you have the x value of your vertex, you can plug it into the equation for x to see what the value of y will be for that vertex. Okay, so it's just a little bit of a review. Number 4, how many solutions do each of these have? So you're going to be looking for the number of solutions. Here, if we take the square root of both sides, we'll get a plus or minus 9. So we know that this will have 2 solutions. Here, if I take the square root of both sides, I will get an imaginary number, so this will be none. There's no real solutions to that. Here, if I were to add 6 to both sides and take the square root, I would have 2 solutions, albeit 2 irrational number solutions, but still 2 solutions. Here, I would get -25, so this will be none. There's no real solutions here because this would be taking the square root of a negative number. Here we have 2, so you can take the square root of both sides and get a positive or -1. Here is interesting because we have equals 0. And so this means that there are only, we would have x minus 8 times x minus 8 equals 0. So here is only one solution. It would be the same solution. And then here we can rewrite this as x plus 1 squared equals 5 and take the square root of both sides. You would get x plus 1 equals plus or minus the square root of 5. So there are 2 solutions. Again, they would be irrational, but 2 solutions. All right, our last one is a real life situation-ish. A frog jumps in the air. The height in inches of the frog is modeled by this function, where t is the time after it jumped, measured in seconds. It says solve 60t minus 75t squared equals 0. What do the solutions tell us about the jumping frog? So you can solve this in any way that you know how. You can use your quadratic function, you can use factoring, whatever you would like. The solutions, though, are going to tell us when the frog, landed. And looking at this, I think the easiest way is to try and factor something out here. So I'm going to factor out the t, and I'll be left with 60 minus 75 t equals 0. This means that t can either equal 0 or t can equal 60 minus 75 t. All right? I'm sorry. 0 can equal 60 minus 75 t. So I can go ahead and subtract 60 from both sides here, and I will get negative 60 equals negative 75 t, and then divide both sides by negative 75. And we will get a very small decimal of 60 divided by 75, which is 0.8. So the frog is on the ground at 0 seconds. That makes sense because he starts on the ground and then he jumps up and comes back down. And he's a little froggy, so he's only going to be in the air for 0.8 seconds. All right, that is your homework for tonight. Your code word is toad, since we had a final question about a frog. Toad is your code word. And I will see you tomorrow. Happy homeworking.